Okay, this is Surveying Practical 4, this is the briefing video. The aim of today is to do another control survey, so it's very similar to Surveying Practical 2. So in Surveying Practical 2, you had one known point, and you had two unknown points, and they formed a triangle. Then you moved from your known point to your unknown points, and by taking a reference bearing to the north direction, you measured the angles between each of those lines. In Surveying Practical 4, what we're going to be doing is we're going to have two known points. So in this case, they're probably going to be an A point and an E point, but they will all be given to you on the day. And you've got two unknown points. This is more typical for a highway project because you can imagine you might have two known points, two benchmarks along a new stretch of highway that you're designing. And then you can carry out the traverse exercise to set up your control points between those two known points, and it'll be a linear exercise, not a loop exercise. So this first one is very much a loop traverse. This is what we call a link or a linear traverse. But the process is the same. So we start at a known point, we move to each unknown point in turn until we reach our final destination. And we obey the same rules as we did before. We always need a reference point, so in this case we're going to use north as our reference point for both A and E. We always measure to the left of the survey line and always in a clockwise direction. So we'll measure that angle, and this angle here. So as you can see, the direction of the survey line is here, and if I'm looking from my starting point to my next point, I want to measure the angle on the left-hand side, and that's really important. So this diagram is similar to the one I just drew. We've got points with known coordinates, which would be your A and E points, and you've got your unknown points, so control point 1, control point 2, which are the points for which you need to find the X and Y coordinates. As I said, we're moving in a line from the known point through the unknown points to our last known point, rather than going back to A, like we did in Surveying Practical 2. So let me show you how that's going to work. Total station, because we need to measure angles, so we have to use the total station. Remember, we want to get to second accuracy. So put the total station over A. This will be your first setup point when you get out on the field. Total station over A. You will also need a prism station set up over control point 1, so that you can then use the compass to find north and measure the angle between north and control point 1. Remember, it's on the left-hand side as you look towards your next point. You'll take a face left reading, a face right reading, looking towards north and also looking towards control point 1. So all in all, you're taking 4 readings at A. Total station moves to control point 1, prism should be at control point 2 and A. And then you need to measure that angle. Again, look at it, it's on the left-hand side. Face left, face right to A, face left, face right to CP2. Move the total station to CP2. Take the angle, face left, face right between CP1 and E. And finally, you want to put the total station over your known point E, or your last known point. It might be called something differently. You need one prism station on control point 2, and you're going to use the compass again to find north, and you're measuring the left-hand angle. But see, in this particular case, it's a very large angle. What you really don't want to do is sometimes measure on the left-hand side and sometimes measure on the right-hand side. And that's going to be really tempting at the last station, because many of you are going to have a very acute angle on the right-hand side. That's not the one you want to take. You want to always take that left-hand side angle. So it's not that, not this one. Always on the left-hand side, in the direction of the survey line. Now, I'm going to take you through the booking. If you're happy with getting reduced angles, etc., you don't need to watch this little bit. If you got your surveying 2 exercise wrong and you didn't have the correct reduced angles or the correct mean angles, you need to watch this more carefully this time. So I'm going to go through each stage. Total station is at A. So in the from column, we always have where the total station is. So we're at A and we're looking to north, very first of all. Sitting at A, looking to north. We can measure the face left reading to north and say that comes out as 865930. We can then swing that round to CP1. Now I'm going to do that because it keeps it on face left, and then I can change it to face right and take those 2 readings again, but you can equally take the face left reading to north and the face right reading to north straight after. So we're A, we're looking at CP1. And the face left reading to CP1 is 2505329. Now swing the total station round to look at CP1. Switch it onto face right. The angle on face right is 2665928, and the face right reading to CP1 is 705325. Remember, the mean, you want to write it in terms of face left. And with face left and face right reading, because you really want to dial, they should be 180 degrees out. If you were being perfectly accurate and if your total station was perfectly calibrated, you would expect to get a reading within a couple of seconds. But that means your total station has to be exactly over the point, has to be exactly level. If it's not, you're not going to be getting that accurate reading. So to get the mean, we have to either take away or add 180 degrees to the face right value, and that's to bring it in line with the face left value. So you can see for the first line, you need to take away 180, then add them together and divide by 2. So what that ends up looking like is 865930 plus 2665928 minus 180. And divide that by 2. And that gives us our mean reading, which will be 865929. Same thing for the angle measured from A to CP1, but this time because face right is less than 180, we need to add 180. So we're going to do 250, 5329, plus 70, 5325, plus 180, divided by 2. And that gives us the mean in terms of face left. So 250, 53, 27. Now for the reduced angle, the first measurement made from any total station point will always be 0, 0, 0. We can and then get this reduced angle for A to CP1 by subtracting the mean angle read to that first point. So the reduced angle here is going to be 250, 53.27 minus the mean angle from A to north, which was 86, 59.29. In effect, that's what we've also done here. We've taken away that first angle from the value. So what we've got is 86, 59, 29 minus 86, 59, 29. So what we're going to do is take away this first reading, 86, 59, 29, from the mean angle here and the mean angle here. That leaves us with 163, 53, 58. You should all have enough spatial awareness to work out whether the angle you're measuring is obtuse or acute or reflex. So 163, according to my diagram, that's about right, because 180 degrees would be here. So yeah, I can accept that that's about 163 degrees. Now, if you got an angle that looked, when you did your reduced calculations, that was over 180 degrees, but you knew that you didn't have an angle over 180 degrees, then you've got to redo it. Because you're going to have larger groups this time, you should be doing the calculations as you go along. So bring a calculator and make sure that at each point you're doing the calculations as you go along, because it's going to save you time and you won't have to then repeat the exercise later on. So I'll go to the next page and I've got all of the values written out. Now notice that the reduced angle is 0, 0, 0 for the first measurement taken at each point. Now a really common mistake in Surveying Practical 2 was to take away all of the angle, take away the first mean angle from all of the rest of the angles that had been measured. That's not going to give you the right answer. You need to remember that the reduced angle should always be 0 at the first point. So the first angle measured at CP1 should be 0, 0, 0 reduced. The first angle at CP2 should be 0, 0, 0 reduced. If you're at all confused about this, pause the video, watch it again, pause the video, and then do the calculations yourselves to satisfy yourself that you know how to calculate the mean and you know how to calculate the reduced angles. Now we need to calculate the misclosure. Some of the angles should equal the final forward bearing minus the initial back bearing, plus m times 180. So the sum of the angles is the sum of those angles that have been measured previously. So it would be this angle, plus this angle, plus this angle. Yep, and I can do a quick reality check. I can see that my angles at CP1 and CP2 should be about 210, 220 degrees. And my angle at E is very large, it's a reflex angle, almost 360 degrees. So I'm happy with those. I want to sum all of those angles up. So 163, 53, 58, plus 217, 241, plus 214, 932, plus 304, 53, 45. So the sum of those angles comes out as 899, 59, 56. Just a little bit shy, 4 seconds shy of 900 degrees. So we check that by looking at the final forward bearing minus the initial back bearing. Because we've used north, this is quite easy. Our initial bearing and our final bearing is going to be 0, 0, 0, because we're looking at north. So the bearing from A to N is 0, 0, 0. the bearing from E to N is also 0, 0, 0. But that's only because we used north as a compass. If we had used another point, we would have to have calculated that bearing, because it wouldn't be 0, 0, 0. So final forward bearing minus initial back bearing, 0, 0, 0 minus 0, 0, 0, plus m times 180. Remember, m is equal to n minus 1, n, or n plus 1. It just depends on the shape of the traverse measured, but what we'll do is just to trial and error for this. Now, n is the number of angles measured. We've measured 4 angles. So m is either equal to 3, 4, or 5. Three times 180, 4 times 180, 5 times 180. 540. 720 or 900. And what you're looking for is the closest match to the sum of your angles. Now, if we've got it really clearly here, we can see that the sum of the angles is nearly 900 degrees. So therefore our misclosure is 8995956 minus 900 degrees. It's minus 4 seconds. So we need to distribute that evenly over each of the angles that have been measured, and I'm going to do that as I put it into the traverse booking sheet. Because you've got a misclosure of -4, the correction is going to be, and you've got 4 angles, the correction is going to be +1 second for each of those angles. Back bearing AN is 0, 0, 0. The angle at A we measured as 163.53.58, but I need to add 1 second correction to all of the angles. Do the same for all the others. I'm going to write the angles out first. So the angle at CP1 we measured was 217.0241. I need to add 1 second correction, so it becomes 42. Angle at CP2 was 214.0932. Add 1 second for 33. And 304.53.45, but I add 1 second to make it 46. If your misclosure is over the sum of the angles, so over 900 degrees, for example, you have to just take away this correction. The correction depends on whether you have come under or over your target angle measurement. So let's go through the calculations. For the forward bearing, we just add the back bearing to the angle at that station. So the first one is dead easy. Now, for the back bearing CP1 to A, just as you stood at A and you measured the angle to CP1, and that bearing is 163.53.59, if you move the total station to CP1 and look back at A, the bearing, the whole circle bearing you're measuring, will be 180 degrees out from that. So we need to either add or subtract 180 degrees. The rule is, if the forward bearing is under 180 degrees, we need to add 180 degrees. If the forward bearing is over 180 degrees, we need to subtract it. And that there's nothing complicated about that. That's just so that we can keep the angles, all of the angles in this booking sheet, to between 0 degrees and 360 degrees. So I'm going to add 163.53.59 to 180. we get 3, 4, 3, 53, 59. I'm going to add that to 217 to 42. And oh, look, I get 560, 56, 41. Now I'm writing it in the corner just because I don't want to write anything that is either less than 0 or more than 360 in this booking sheet. Therefore, I need to subtract 360 degrees from this value. And I get 256.41. Why? Well, I'll explain this by this. We have a dial. You can measure degrees between 0 degrees and 360 degrees. If I've got an angle 560 degrees, that is 200 degrees over 360, so it's somewhere here. So I could either read it as 560 degrees, or I could read it as the equivalent value of 200 degrees. Because they're the same angle, because we're going round in a circle. So all we need to do to get that is subtract the 360 degrees. It's a really, really good idea whenever possible to draw out these angles, draw out your plan. Because this is just geometry, and you can understand it either by looking at it from a purely mathematical point of view and adding things up and taking away when you're meant to, or you can think about it logically. What does that angle mean? What does it look like? Where is it measured from? So we're carried on with that. We've got 256.41. Because we're over 180, I need to subtract 180 to get 20.56.41. I'm going to add that to the internal angle, 214.933. We get 235.06.14 minus 180. 55.640. Now here's the test, because if I add this number to the angle at E, and I've done my corrections properly, I should get my initial back bearing back at the end. So I'm adding 55.614 to 304.53.46, and now we get 360.00. And that's because the back bearing, initial back bearing A to N, also equals the final forward bearing E to N, which was 0, 0, 0. I can write it as 360, but remember 360, 0, 0 is equivalent to 0, 0, 0. Because we're interested in the bearings, I'm just going to write those final forward bearings in the bearing column. So 163, 53, 59, 200, 56, 41, 235, 06, 14, and let's write this as 0, 0, 0, just to bring it back. The distances were measured as well, so I can transfer those across. You should be doing face left distance and face right distance at each point. So the distance between A and CP1 was measured face left, face right, and the mean is 21.761. It's in the booking sheet if you want to slip back and have a look at that. We've also got the distance between CP1 and the CP2. That was measured face left and face right, both from CP1 and from CP2, so you need to average them. And the average distance is 20.562. And we've got the distance from CP2 to E, which again was measured from CP2, and then again from E, face left, face right both times. And the distance given was 27.211. The aim then is to take all of this data and fill in the main traverse sheet. Now I'm not going to do that because I've already gone through the process and it is identical. So do have a look back at your notes, have a look back at the lecture slides, have a look back at the video on the link traverse, which was a good while ago now, well before Easter. You've got two different methods for corrections. You can either use the transit method or you can use the Bowditch method. I don't mind, either's okay. Other than that, it's just a matter of computing the delta eastings, delta northings. So delta eastings is going to be your distance multiplied by the sine of the whole circle bearing. Delta northing is going to be your distance multiplied by the cos of the whole circle bearing. Once you've computed your delta eastings and delta northings, you can work out your linear disclosure because you also have your coordinates at A and at E at your first and your last point, so you're looking at the difference. You can then distribute the distance using either the transit or the Bowditch method, compute the final coordinate differences and the final coordinates. And that's it. Yeah, have a go.